All right, in this video we're going to look at average velocity and speed in a little more detail. We're going to take our buddy from the first example who started at his origin, his reference point, and went to McDonald's to get a bite to eat, then went over to his Frankie's house, his buddy's Frankie's house, and then went back to school. So we're going to add in a fourth position. Notice x1 is where he started, x2, second position, third position, fourth position. So he's moving back and forth, and we're tracking now his motion on a timeline. So the timeline's showing the clock time that's elapsed during his during his three stops beyond his original. So at time 1, he's at position x1, which is 0. So time 2, he's at x2, which is his stop at McDonald's. At time 3, he's at Frankie's house, which is position 3. At time 4, he's at school, which is position 4. Notice this is clock time, not time interval. So we're going to have to use the difference between the clock times in order to find his different velocity and speeds at different points. So let's look at finding some average velocities first. So average velocity we've defined as the displacement or the change in position of an object over a certain time period or time interval that has elapsed. So let's look at the average velocity from position 1 to 2, from 2 to 3, and from 1 to 4. So delta x over t. So from velocity average from position 1 to 2 is my change in x from 1 to 2. So I start at 0, I end up at 2400. We're going to use the meters. So 2400 meters over 0. Delta t, I go from 0 to 156 seconds. So 2400 meters over 156 seconds gives me 15.4 meters per second. And as a rule of thumb for rounding, we will use significant figures or significant digits, however you want to call it, whatever the minimum is. So 3 here being 156, so I'm going to go 15.4. I should say this is put a decimal there to indicate that these are significant figures, the zeros. They're not rounded. All right, another handy thing in speeds, meters per second is not something we use every day. Something we use every day is miles per hour, and there's a really quick conversion between meters per second and miles per hour. If you look at the actual conversion here, which I'll zoom in a little bit, if we start with meters per second, there's 1 mile for every 1609 meters, and there's 3600 seconds in every hour. So multiplying this out, I get about 2.24. So we can say, as a rule of thumb, about 2 miles per hour for every meter per second. So if you take your meters per second and double it, plus a little bit, you're going to get your approximate miles per hour. So my approximate miles per hour here would be 31 or so, 31, 32, somewhere in there. All right, from 2 to 3, change in position is I start at 2400, I end at negative 1800. So negative 1800 minus 2400 meters over, I go from time 156 to 421. So I've got negative 4200 meters over 265 seconds, which gives me a negative 15.8 meters per second, or about negative, let's say, 32 miles per hour. Notice negative velocity. Negative velocity means my position is changing. I'm going back towards the origin or away from the origin in the negative direction, which is from here to here. You can see that from the map. That's what I'm doing. All right, last one. From 1 to 4, what's my average velocity? Delta x over t. From 1, I start at 0. I go up, down, and back to 0.7. So I'm just interested in where I started minus where I finished minus where I started. 672 seconds goes by. So 700 over 672. And again, put a decimal here. We'll consider those 3 significant figures. So my average velocity is 1.4 meters per second, or about 2 miles per hour. All right, so that's average velocity. Notice velocity average can be negative. It's only where you started to where you ended in terms of position. divided by the time interval that elapsed. The other thing that's useful that comes in to play is speed, average speed. Let me zoom back out a bit. Now, average speed is only concerned with the total distance traveled in the certain time period that has gone by. So think of this as your speedometer reading on your car, right? Your speedometer reading is never negative. It's always positive, and it's looking at that instant, how much ground are you covering, how much distance are you covering in a certain amount of time that goes by. So let's look at speed from 1 to 2. Well, I start at 0, I end at x2 2400. I travel a distance of 2400 meters. That's the same. 156 seconds goes by. So my speed, 15.4, meters per second. Get my 4 in there. About 31 miles per hour. So it's the same. Notice speed and velocity can be the same. Not always, though. So from 2 to 3, I go from here, position 2 to position 3. That's a total distance of 4,200 meters. Notice it's not negative because I'm not worried about direction with distance. The time that goes by, same here, 265. But instead of a negative 15.8, it's a positive 15.8 meters per second, or 32 miles per hour. And then finally, from 1 to 4, let me get this focused a little bit. Total distance from 1 to 4 over the time that has elapsed. So the easy one is the time interval, 0 to 672. But now I need to add up all the distances I traveled. So I go 2,400, back 2,400, back 1,800, back 1,800, forward 700. So 2,400 plus 2,400 plus 1,800 plus 1,800 plus 700 gives me a total of 9,100 meters traveled. So this is going to give me a big difference in overall speed versus overall velocity. So about 27 miles per hour. Okay? So remember, average velocity, you're only interested in the 2 different positions, where you started, where you finished. Average speed, you're interested in the total distance traveled. Now I'm going to give you a couple problems for you guys to solve on your own. So take the same timeline, the same position, and now I want you to find the average velocity and the average speed from positions 1 to position 3 and positions 2 to positions 4 in meters per second as your standard units, and then do an estimate in miles per hour for each. So pause the video right now and set that up, and then I will post the solutions in a second. Okay, here comes the solutions.